Hello, this is a quick look at a more advanced version of the way in which we make our trees blow in the wind. In this structure, we're using our UV coordinates to carry some object space information about our object into our 3D program. So if we go back to our example here, we can see that our batched world space has a central pivot point. However, that pivot point can change wildly dependent on where our object is in the world. And even more importantly, if we have about 100 objects all batched together, we'll have one pivot point for all of them, so we'll have no way to tell where the center of the object is. So in this setup, what we want is a plane that will tell us where the center point of the plane is, so that in this context, all of our two-dimensional trees, our sprite trees here, will stare at the camera. So this is being done without any code. There's no animations being applied. All of these trees are simply staring in 2 dimensions at wherever the camera is. This is part of a prototype project that I'm working on using a beautiful art style by an excellent artist that I have the privilege of being able to work with. So if we jump into our max scene, what we're doing here is we're using our UV coordinates to carry information about our object space position. So what we want to know about our plane here that we have our tree texture projected onto, we want to know where is the base of the tree on this plane, and then when we bring it into our game program, we want to make sure that that base is carried on even if we combine together a whole bunch of these different planes. So in our UV2 construction here, we have our setup so that you can see that it's a perfectly flat line. And what we're doing here is we're using it to be able to establish where our 0 point is in our Z direction. And if we open up our UV, whoopsie daisies, if we open our UV1 channel, you can see that we're mapped like this. So if we know the size of our quad, and we know that our UV coordinates go from 0 to 1, and we know that the center of the tree is at the base of this center line here, we can carry that information through into our 3D program, or in this context, our game program, and we can tell it, and I won't go into too much detail because the shade is a little complicated, but we can say, well, here's our camera's position, here is where the center of our tree is, I want you to rotate our vertexes around that center point so that they always look towards the camera. And if you look at our tree here, you can see that it's doing that. And in exactly the same way, we can use those same numbers and control values to be able to control more information about our tree. So in this context, we can change our overall height of our trees, we can control our width, we can control our variance in height so that they'll all begin to become very similar. We can control our variance in width. So this allows us to have a lot of control over these objects. And what's really fascinating about this is that each of these objects is being controlled in its own object space. So this also means that we can, as you can see here, the tree can have a different height based on where it is. In this one, we've done quite an extreme version. It hasn't been controlled in any real way yet, but you can see how it moves and changes size. This is because our object has its own object space position that each of the vertexes can reference. This can be really useful for other effects where you want to be able to scale an object, or you want to be able to have objects have different colors within your scene just by placing them down. And we can do this, instead of having to do it at a vertex level, we can do it at an object level. Now what's important about this is that typically your game object doesn't have an object space position as a piece of information that it carries with it. When we look back at the way that our rendering engine works, it really only looks at triangles or vertexes. And those vertexes and triangles, those vertexes know nothing about any of the points around them. The triangles might only know the information that relates to that vertex. And even then, that only really runs these days in DirectX 11, where you have your triangle shaders, or your vert shaders in this context, so your geometry shaders. So if we go back into our scene, you can see that each of these carries its own world space position, and if we were to run into our game camera, make sure that all of these are set to static. Whoop. They'll still continue to turn. Now if we look in our game camera, you can see that we're batching pretty much all of them to create a very, very small number of actual trees that it thinks that it's absolutely rendering. And what this means is that we can move that camera around the scene, they'll always look at them, but from the perspective of our program, they'll be treated really as one piece of geometry. So I hope this helps kind of spark some ideas of the different things you can do by trying to carry that information into your game engine.